So we're finishing off our notes from section, or I think we had, I don't know if we gave it a section. It was on dividing polynomials using long division. Okay, and remember we had a warm up in there, and then you had like 2 pages of notes. All right, so let's look at one more of these. And remember that when we have this little -1, that this really means this. Now, if we could factor, that would be an option. However, we can't factor this one. But no matter what, I want you to do these by long division. Okay, so I'm going to rewrite it as x minus 1 divided into. Now, when I'm doing these problems, it was just nice and convenient that they weren't missing any terms and that they were in order. So see how it's got x squared, x, and then a constant. Okay, that's going to be something that you're always watching for, that these are always written in standard form and no pieces are missing. Okay, so remember that we said this is a binomial, so I start 2 over. I start right there. And I say, what times x is x squared? And that would be an x. So x times x is x squared. X times -1 is negative x. And then I'm going to subtract. And you've got to have that right there, that line. Okay, 5x plus 1x is 6x. And I'm going to bring down my -7. Okay, now I'm thinking, what times x is 6x? Remember, I don't care about that -1 at all. I don't care about that -7 at all. Just these first terms right there. Okay, so this is going to be a positive 6. So 6 times x is 6x. 6 times -1 is a -6. Now I have to subtract. And this becomes -1. And that's my remainder. Okay, so I'm going to write my answer over here on the side. My answer is x plus 6 minus 1 over x minus 1. Okay? All right, now let's look at a couple of things that can happen if things are missing. Okay, so say we have a problem like this. Okay, so this is a division problem. We can't factor the top. That's the sum of 2 squares. You can't factor the sum of 2 squares. Okay, so it's the top divided by the bottom. So I'm going to rewrite it. Now, I'm going to be careful because in this case, it's missing the x term. So I have to put it in. Or I shouldn't say put it in, I should say hold its place. So it has a 0 right there. Okay, now this is a binomial. Even though there's a 0, it's like having the number 105. We put a 0 in to hold that spot. Okay, so I'm going to start the regular way. What times x is x squared? That would be x. So x times x is x squared. X times -3 is -3x. Okay, now I'm going to subtract. So 3x plus 0x is just 3x. Okay, what times x is 3x? Positive 3. So 3 times x is 3x. 3 times -3 is -9. And I'm going to subtract. Okay, and I know that's my remainder because I've covered up all the pieces on top. Okay, so my answer is x plus 3. Now don't forget right here, this is a positive 13. So now I have to have plus 13 over x minus 3. And there's our solution. Okay, let's look at another one here. Okay, so let's say we have something like this. X squared plus x times x plus 4 to the negative 1. Okay, so again, remember, that's actually a division problem. This says x squared plus x divided by x plus 4. So here's a case that we're missing the constant term. We have it going in order, x squared x, and there's no constant. Okay, so I'm going to rewrite this. So x plus 4, and I have x squared. So I have to have all of the pieces. So I'm just going to put a 0 for my constant. Okay, x squared, x constant. Okay, two terms right here. X times x is x squared. X times 4 is plus 4x. I'm going to subtract. X minus 4x is negative 3x. I'm going to bring down my plus is 0. Okay, what times x is equal to negative 3x? Okay, now I'm going to multiply. Negative 3 times x is negative 3x. Negative 3 times positive 4 is negative 12. I'm going to subtract. That becomes a positive, and that's my remainder. So my answer is x minus 3 plus 12 over x plus 4. Okay. Okay, one more. I don't know if I'm going to have enough room on this page, so I'm going to put it on the back page here, or the next page. This one's a little bit, I'm going to do a long one, because the ones that we're starting out with right now, they usually get a little bit longer than this. So let's try one, see if we can do it. Okay, so let's do x minus 2. I guess it would help if you could see it, into x cubed plus 2x squared minus 6x minus 9. So notice that there's no missing pieces, that it's got an x cubed and then it has to go down. X cubed, x squared, x constant. Okay, so I'm going to put that over here. Okay, and then eventually we're also going to have like trinomials out here, so something other than a binomial. Okay, this has two terms. I'm going to come over two terms. Now I'm thinking, what times x is x cubed? That's going to be x squared. Now I'm going to multiply. X squared times x is x cubed. X squared times negative 2 is negative 2x squared. And I'm going to subtract. That's 4x squared. And I'm going to bring down my minus 6x. Okay, what times x will give me 4x squared? a positive 4x. So now I'm going to multiply. 4x times x is 4x squared. 4x times negative 2 is negative 8x. Okay, now I'm going to subtract. So 8x minus 6x is 2x. I'm going to bring down my 9. Do it all again. Okay, what times x is 2x? Positive 2. Okay, so 2 times x is 2x. 2 times negative 2 is negative 4. I'm going to subtract, and that will give me a negative 5. So my answer is x squared plus 4x plus 2 minus 5 over x minus 2. Okay, so what you guys are going to do from here on out, I'm going to post this up. I will link it into, wrong one. I will link this on our Canvas page, but you are going to do assignment number 11, which only has 4 problems. You're going to be using pencil, okay? I don't want pen and I don't want scribbly stuff. I want it nice and neat. I want, when you're adding and subtracting, I want lines in there, okay? So nice and neat. Like I said, I'm gonna put this up on Canvas so that you'll know what problems to do. And then before tomorrow morning, you're gonna submit your notes, okay? So starting with back here on divide polynomials using long division, and then all of those examples, and then a picture of those 4 problems. All of that before class tomorrow. All right, you guys, have a good night.